So today we're going to talk about absolute values and how to graph them as an inequality on the number line. So we have a number line here, and I have your negative and positives. We remember that absolute value is simply the distance an integer is from 0. So that means, because of that, all of our absolute values are going to be positive integers. So the absolute value of a negative 5 is 5. Absolute value of negative 4 is 4, and so on. Because they're just the distance away from 0, the number of spaces away, regardless of what that space is. So for the negative 5, we know it's 5, 1, 2, 3, 4, 5 spaces from 0. It's just a distance. And the reason the absolute value is always positive is because a distance has a real value. It's not negative. It is a length, and length is always a positive number. So that is why the absolute value always has a positive value. It's because it is a distance. So when we have an absolute value in an inequality statement, we have to kind of look at it that way. We have to remember what it actually is. So if I were to have the absolute value of x is less than or equal to 3, let's say 3, I have to take into account the fact that this x could be a positive 3 or it could be a negative 3 to make this a true statement. It could be anything between a negative 3 or a positive 3. So it would be this group right here. So it would be a conjunction. So I have to rewrite this as both a positive and a negative. So I have the positive value is going to be less than or equal to 3. But then I also have the negative value of x is less than or equal to 3. Now, to change this, we don't like to have a negative x. Our variables, we want them to be positive. So we multiply that times the negative 1, and that's going to equal x is greater than or less than a negative 3 because we multiplied negative 1 times each of these three elements and flipped them. We flipped the one in the middle in order to affect that change. So to write this or to graph this on our number line, we're going to write it as a conjunction first. And the way we do that is by flipping this around. And when we flip this around, we have to flip our inequality. So we're going to write negative 3 is less than or equal to x because that's what we're saying here. If we read it from this way to this way, negative 3 is less than or equal to x. So we just wrote it in the opposite direction. Now we can take this and we can actually stack it under or kind of overlay it on top of the other x so that we have one statement. So now we have negative 3 is less than or equal to x, which is less than or equal to 3. So that's what we would graph. Let's take this, this green right here, and I'm going to include, by filling in the circle, the negative 3, and I'm going to include the positive 3 and fill that line in. Now the reason that makes it a true statement is because I could say negative 2 is less than or equal to 3. The absolute value of negative 2 is less than or equal to 3. The absolute value of negative 2 is a positive 2. Positive 2 is less than or equal to 3. So that all of these numbers from negative 3 to positive 3 make this a true statement because we understand that the absolute value of these are going to be positive. So we have to include them as well. All right, so let's clear the page and let's actually apply this to a real problem. All right, so here we have 99.1. We have the absolute value of x is less than or equal to 4. So we are going to rewrite this as the absolute value of x is less than or equal to 4, and the negative x is equal to less than or equal to 4. So now we're going to multiply this by negative 1, which is going to flip it all. So we have a positive x is greater than or equal to a negative 4. Then we're going to rewrite that backwards. So we put the negative 4, we flip the sign, and we put the x. We just wrote it in the opposite direction. So now this is a true statement. Negative 4 is less than or equal to x. Negative 4 is less than or equal to x. It's the same statement, it's just written in the opposite direction. Okay? So now we can put this with the other. So we're going to put negative 4 is less than or equal to x, and x is less than or equal to 4. So x is less than or equal to 4. And that's how we're going to do our conjunction. And it is in the domain of the integers. So we are just going to mark the integers. So we have negative 4, it is equal to that. So we're going to put negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. And you can always check this by picking one of these. Let's pick number negative 2 and let's rewrite it. Negative 4 is less than or equal to negative 2, which is less than or equal to 4. So negative 4 is less than negative 2, and negative 2 is less than positive 4. So that is a true statement. So all of that is a true statement. And we have what we need for our conjunction, and this is how we would graph that because it is integers, not reals. Reals, you draw the line. Rationals, you draw the line. Integers, you just dot the actual integer. All right, so let's look at 99.2. All right, in 99.2, it says to graph the negative absolute value of x plus 3 is greater than 0 in the domain of integers. So first we need to solve this and find what the value of x is alone on one side. So we're going to solve for x. So we bring this down. So first let's address this plus 3. We want to get x by itself. So we're going to add a negative 3 to both sides. So that tells us that the negative absolute value of x is greater than negative 3. We don't want to have a negative absolute value of x. We want to just have the absolute value of x. So we multiply everything by negative 1. So the absolute value of x is less than a positive 3. Okay, now we can take this and do our conjunction. So we have x is less than positive 3, or negative x is less than positive 3. Multiply this by negative 1, and that's going to equal a x is greater than negative 3. We rewrite this backwards. We read it the other way. Negative 3 is less than x. As long as the point here is pointed to the same value and the open side is facing the same value, when you rewrite it, you know that's true. So this should flip. If these two flip sides, then your inequality has to flip sides. So we take this part and we put it together with this one, and we write negative 3 is less than x, and then we pick up here and say x is less than positive 3. So that is how we would graph that. It's in the domain of integers, so we're just going to put dots on those. So we start at negative 3, but it's not equal to negative 3. It's less than negative 3. So we go to the next integer. Negative 2 is greater than negative 3. Negative 1, 0, 1, and 2. Now we rewrite that. So let's write it with the number on the end, on both ends, just to make sure it's a true statement. We're checking our work here. Negative 3 is less than negative 2, which is less than a positive 3. That's true. Let's try the other end. Negative 3 is less than a positive 2, which is less than a positive 3. And that checks out too. So we know we have written a correct statement, or we've written our conjunction correctly. We've checked our conjunction with what we graphed by dropping in the numbers on each ends, and they are both true. So therefore, we have graphed it correctly. All right. So let's move on to absolute value disjunctions. That's where they are not connected or overlapping one another. So with a disjunction, we're going to have a very similar process. Let's do 99.3. And this is going to be in the domain of reals. So it tells us we're going to actually graph the line, not just the dots on the line. My brackets look terrible, but we know they're brackets. Nothing else looks like them. Okay, so let's do what we normally do. We're going to subtract 2 from both sides because we want to get x by itself. So the negative absolute value of x is less than a negative 4. We don't like that, so we multiply by negative 1, which flips everything. So the absolute value of x is going to be greater than a positive 4 because we multiplied this by negative 1. That changes that value. So now we can rewrite that. X is greater than 4 and negative x is greater than 4. We don't like that statement, so we multiply everything here by negative 1 because we don't want a negative x, do we? So x is less than 4. So what we have here is a disjunction. We have this is a negative 4. 4 times negative 1 is negative 4. Negative 4 is greater than x, and 4 is less than x. Positive 4 is less than x. So we are going to look at how that works on our number line. So remember, we're talking about absolute values. This is all absolute values. So we have to write our absolute values here. 5, 4, 3, 2, 1, 0, and of course 1, 2, 3, 4, 5. So on our number line, we're going to look at these two. These cannot be written together because they are opposites of one another. They're disjunctions. So x is greater than 4. If we were to try, we would say x is less than negative 4. But x is greater than positive 4. So that's going to be kind of hard to do. Negative 4 is greater than x, and x is greater than positive 4. So we know that everything on our number line, as it goes this direction, is going to get smaller. So negative 4 is greater than everything to its left. So what happens is everything here, we're going to circle 4, and everything else this direction is included. But then looking at x is greater than 4, we're going to circle the 4 and then go to the right. Everything there is included. So all of these numbers in the middle are not a part of this disjunction. They're not a part of the values of x. X is negative 4 or less, and positive 4 or greater. And the reason for that is because of the absolute value. That is how you would graph that absolute value is greater than 4. Because 5s are greater than 4. So it's a little bit tricky, but that is what you are doing. And this really is hard to understand, but that's how you would write a disjunction of x. So let's look at dealing with negative numbers in an absolute value situation. When we have a negative number, let's say we are given that the absolute value of x is less than a negative 3. Let's think about that for just a moment. The absolute value of a number is always positive. So even if let's say I put a negative 3 in here, the absolute value of negative 3 is 3. That cannot be less than negative 3, right? If I put in 0, the absolute value of 0, 0 is still greater than negative 3. So there is no absolute value that you can put in that would be less than any negative number that you wanted to substitute in. So when you have the absolute value of a number is less than a negative 3, there is no solution to it. So that's what we would write. We would say equals no solution, because there's not one. You can't solve this. And the same is true if you were to say, well, not the same is true. The absolute value of x is greater than negative 3. Well, the answer to this is all numbers. You don't even have to solve it, because the absolute value is a positive. It's always going to be greater than whatever negative number you put in here. So the absolute value of any number is going to always be greater than a negative integer. So therefore you can say all numbers whenever you see something like this. These are considered trick questions in math, so be aware of those. If you see something like this, the absolute value is less than negative 3, it's no solution. The absolute value is greater than a negative number, the answer is all solutions. So either no solutions or all numbers. You could say all numbers or all solutions. Either one is true. Either one is accurate. I'm fine with either. All right. But if you type it into your system and you type in all solutions and it tells you it's wrong, try typing in all numbers and see if that doesn't solve that. So let's look at 99.4. We have two scenarios here. We have the absolute value of x is less than negative 2. Actually, that's the one we just did. So we don't have to do 99.4. We just did 99.4. Let's do 99.5. So we have negative x minus 5 is greater than negative 3, and the domain is integers. All right, so don't immediately say, oh, it's a negative 3. We've got a number here we have to deal with first. So solve this first and then evaluate your system. You got to get x by itself first. So we're going to add 5 to both sides. Negative absolute value of x is greater than a positive 2. Now we multiply by negative 1. The absolute value of x is greater than a negative 2. We just looked at this. So let me change this. I didn't change my sign. We just looked at this, so we know that a positive cannot be less than a negative. So this would actually be a no solution problem. And that's how we would solve that. And that is correct. So don't automatically assume that just because it's a negative number, it's going to be that. Solve it first and then let it play out. And when you get down here to the very bottom, where you have everything else taken care of, and you get down to your absolute value and a positive absolute value of x, then look at this number over here and see if it's a positive or a negative number. If it is a positive number, then you can continue. If it's a negative number, it's no solution. All right, that's all we have for lesson 99. I'll see you in lesson 100.